Hi, and welcome to part 2 of the lecture series on the RMC and life safety. My name is Woodrow Fields. I'll be talking to you in this lecture about how risk assessments are made within the RMC, what flavors of risk are used to make decisions, and how those decisions are made. There are many different ways to calculate risk. In dam and levee safety, decisions are made based on the risk imposed by the structure, also known as incremental risk. This is an important distinction to the total risk of a project, which includes risk associated with no failure of that project. The risk assessments done by dam and levee safety are scalable, meaning that we don't want to be spending an exorbitant amount of money on a project that's low risk. So we would go through a screening process up front to screen out those that are going to be low risk no matter what. And then from there, we increase the level of effort commensurate with that risk. Higher level risk assessments will be made on those projects that are deemed high risk. Here's a conceptual risk model. In the conceptual risk model, we have our hazard frequency, our system response, and our consequences. All of those are combined to come up with our likelihood of a given consequence. And that can get us our estimated annual consequences and so on. As an example of the screening process, I'd like to focus on the LEVEE screening tool. The LEVEE screening tool is a tool used in the levee safety community to quickly determine risk for any given project. It starts out by assessing what the return interval is at the toe of a levee and at the top of the levee. And then, what's the probability of failure if that levee was loaded to the top? And finally, what are the consequences if that levee failed when loaded to the top? These three simple functions are then put into a conceptual risk model to assess the risk. Here's an example of various screenings that have been done with the LEVEE screening tool. The y-axis is the annual probability of inundation, and the x-axis is the average life loss. As you can see, as dots move up and to the right, that's higher risk, meaning that the annual probability of inundation is greater and the life loss is greater. As you move down and to the left, you're reducing the annual probability of inundation and also reducing life loss, which indicates lower risk. Now, when we want to get into our higher level risk assessments, we need to start using something other than the LEVEE screening tool. We need to get a better understanding of the various loading frequencies at various points along the levees and dams, not just at the top. There are multiple tools that are available to assess the hazard frequency function. RMC RFA, RMC Best Fit, HEC SSP, and HEC Watt are all tools that are readily available and free to use to get a hazard frequency function that can then be used in your risk analysis. To determine the system response for higher level risk assessments, event trees are commonly employed. Common tools used to develop event trees are RMC Dam Ray, RMC Daemon Ray, and RMC Total Risk, but there's proprietary software as well, such as Precision Tree and Top Event. How an event tree works is you come up with a series of events that would occur to lead to a failure. Each of those events are assigned a probability based off the given loading scenario. Once you've built out your event tree, you multiply the probabilities through to get your overall total probability of failure for that given scenario. You do that for various loading conditions to develop your system response function. To develop consequence functions for higher level risk assessments, HEC LifeSim is employed to estimate life loss for various failure scenarios and non-failure scenarios. Keeping in mind that life safety is paramount in the dam and levee safety community, LifeSim is a tool that has the ability to track individual people throughout the warning and evacuation process. Each person is an individual agent in the simulation. It also has a traffic simulation engine that can be used to estimate the evacuation process. And Monte Carlo sampling is employed with uncertainty to produce a distribution of life loss results. All that said, HEC LifeSim is a fairly complicated tool that's used to simulate the warning and evacuation process combined with the propagation of flood waves from a failure or non-failure scenario to estimate life loss and economic damages associated with an event. You run this for various events to develop your consequence function that can be then used in your risk analysis. Here's an example of the warning and evacuation process in LifeSim. Keep in mind that LifeSim simulates the entire warning and evacuation process, including traffic simulation, to determine where people will evacuate to or not evacuate in a flood event. Based on where they end up, LifeSim then assesses the hydraulic conditions at that location to determine fatality. As you can see here, brown structures are turning yellow, meaning the people in that structure received a warning. Once people who have received a warning decide to take protective action, they turn into a blue car and begin evacuating along the road network. As these vehicles are evacuating, they're interacting with other vehicles on the road, creating potential traffic jams, and interacting with the flood wave as it's propagating through the system. All of these efforts in a higher level risk assessment better define the functions that go into a risk assessment. By better defining the functions, we are going to get more consistency and more confidence in our risk results. You've done it. You've completed your risk analysis. You've calculated incremental risk for your project. You're confident in your results. You've used life loss as the consequence. But how do you make decisions when life safety is the primary decision metric? In dam and levee safety, we use something called the Tolerable Risk Framework. The Tolerable Risk Guidelines, or TRG, are risks that society is willing to live with so as to secure certain benefits. Risks that society does not regard as negligible or something it might ignore. Risks that society is confident are being properly managed by the owner. And risks that the owner keeps under review and reduces still further if and as practicable. Here's a visual example of the tolerability of risk guidelines. On the left is the guidelines associated with individual risk. Individual risk is calculated as a risk associated with the individual who is at most at risk of losing their life due to the flooding event. On the right is our societal risk limits. In the next slide, I'm going to show you an example of how projects are assessed using the societal tolerable risk limits. Here's an example of a project plotted against the tolerable risk guidelines. Keep in mind that if a project plots above that societal risk line, then that's the decision metric that that project has to have its risk reduced. More money needs to be spent to get a better understanding of the risk and what alternatives need to be employed to reduce that risk. Even if a project plots below that line, keep in mind the higher level risk assessments still may need to be employed and alternative analysis still may need to be done to ensure that the risks are reduced further as low as reasonably practicable. This concludes part 2 of the lecture series on the RMC and life safety. Hopefully this cleared some things up and didn't muddy the waters too much on how the dam and levee safety community assesses risks and makes decisions based on that risk. Some important key takeaways is that the risk metric that dam and levee safety uses is incremental risk, or the risk associated with the project. And life safety is the primary metric used for decision making. Also, the tolerable risk guidelines are the numerical metric used to determine if a project needs to be further improved, have its risks reduced, or not. Thank you. Hopefully you enjoyed it, and goodbye.